All right, yes, there we go. With our KQ 2023 at number 19, lesson 2. So the question reads in the figure below, E is the midpoint of AB, then OD ratio, DB is 2 to 3, and F is the point of intersection of AD and OE. So more information, given that OA is equal to A vector and OB is equal to B vector. First question, express in terms of vector A and vector B. Roman 1, AD and OE. 1 mark, 2 marks respectively. Then Roman or part B, given further that AF is SAD, where S here is a scalar quantity, and OF is also TOE, where T is also a scalar quantity. Find the values of S and T. 5 good marks. Then, last but not least, show that EF and O are collinear. 2 marks. So like I promised my students, today we are going to earn 3 marks. My teacher used to tell me section B is 3 marks. Go for the kill. You can't lack your 5 numbers, each 10 marks, and you get your 50%. Remember, our main objective is to make sure we earn as many marks as possible. We earn as many marks as possible, because when we pass in maths, we shall be able to have better courses when it comes to career choice. So let's pay attention and see. So under our solution, we have to interpret this diagram very well in respect to the given information. So we are told point E is the midpoint of AB, and therefore, being the midpoint, it divides it into 2 equal halves. That is ratio 1:1. Ratio 1:1. Then we are also given another information that AD, or let me say OD ratio DB is 2 to 3. 2 to 3. So OD ratio DB is 2 to 3. So there it is. Then they are giving us again. So up to there, we shall be able to tackle Roman A, or part A of the question. And therefore, everything originates from O, so I can show it on my diagram, where vector OA is also given as A and vector OB is a B vector. So there we go. So under solution, we are told to express AD in terms of ratio A and B. So or I'm at A and I want to reach D. How do I move? So I'll come all the way to O, then O to D, because that is where I'm going to pass through the given vectors. So therefore, we all know that when we go against the arrow, the sign changes. In vectors, we deal only with 2 main things: sign and quantity, or size, sign and magnitude. So it becomes therefore A to O, then O to D. where vector OA is a negative of vector A small plus OD. I'm not going a full OB. I'm just going 2 steps out of the 5. So 2 out of 5 of OB, and OB is represented by vector B. So we can leave it there, or some people can rearrange it and say 2 over 5B minus vector A. So this or that is no big deal. Then our Roman 2 of question A, or of part A, we are also expected to express in vector form OE. We are in O, we want to reach E. We are at O, we want to reach E. So we can go either way, but I'll choose to go through A. So if I go through A, my OE, the first step will be from O to A, then A to E. O to A to E. You would have gone this way, it's still the same, so there's no big deal. So there we go. So my OA is vector A. Then AE, there's a ratio here. I'm going halfway. So I'm going half of AB. And therefore, half of AB. AB is simply vector B minus A. A to B, I have to go that way. So minus A plus B. So B minus A. And therefore, this shall become A plus half B minus half A. So collecting the like terms, this is a full A minus a half. So I remain with half of A plus half of B. You can rest it there, or you can factor out half. Half is common, so plus a B. So you can leave it there, or you would have just left it there. They're still the same. I've just factored out half. So up to there, I hope we are all okay and good to go. So going to the second part of the question, and that is where we have good marks. So can't afford to lose them. We are told, given further that given further that AF is equal to S of AD. So like I said, S here is simply a scalar. Just like here we have half A plus half B. So the scalar here of vector A is half. So, or some people can call it the coefficient for that matter, but there's no big deal. So let's see. We are at AF, we are told, is just as a fraction of the whole line AD. Just a fraction of it, might be half, a third, or any fraction, 3 over 5. And also OF here, OF is also T of OE. T of OE. The same thing here. T is the scalar. Is the scalar here, or the ratio at which F divides the whole line OE. So we can go. Then we are told to find the values of ST. Please note here that I would want to tell my viewers and the students that when given such an equation or such an information, always we have to make two expressions of the point of origin to the center point. We have to make two expressions of the line from the point of origin to the center point. Coming to our diagram, point of origin is O and center point is F. So I would expect you to make two expressions of OF. So OF1, we are going to follow, or we are going to consider information 1, that is pass through AF. You are in O, you want to reach F, but you are being forced to pass through route AF. So how do you move? You are at O, you want to reach here, but you are forced to pass through this route. So I will have to go from O to A, then A to F. So it will be OA plus AF. So we come, OA we all know, plus AF is given up here. It's an S of AD. Have we done AD anywhere? Here it is. AD was already solved as AD is 2 over 5B minus vector A. There it is. So we just break the bracket with S. So we shall have 5BS minus SA or AS. So don't leave your equation at this stage. You have to factor. Bring the common factors together. So A minus SA plus 2 over 5BS. So we have to factorize or factor out A. So A shall go there 1 minus S plus 2 over 5BS. This is our equation 1. This is our equation 1. This is our equation 1. There we have. You can follow through slowly and you'll be able to understand. I'm also not too fast because I'm giving you room to follow through. Then, as we continue, we have to make another equation, like I said, of OF. I said in two ways. We have to make expressions of point of origin to the center point in two ways. Then now we have to follow this other part given. In the first step, we considered this. Now we are going to pass through OF. We're just going to jump straight. Rather than going through any other route, we go straight. So we are not going to cover the whole route OE. We are just going to take some fraction, like a third, a half, 1 over 5, whichever. So that fraction of OF is what is represented by T here. It's what is represented by T. So therefore, we are going to say OE is simply a T of OE. Have we done OE anywhere? Yes. Here it is. So these parts of the whole question depends on each other. You cannot afford to miss the first part and come and get this. So that's why we have to be very keen. My teacher used to say in maths we have 3 sisters or brothers. That is being keen, being accurate, and observing time. That is speed. So the moment you neglect one, if you are not keen, you'll be doing your own things. If you are not fast, time will cut you short. And if you are not accurate, then you will be doing your own things. So let's employ the 3 brothers at one. So OF will therefore be T into OE, and OE is half of A plus half of B. So break the bracket. This is more simpler. Half of AT plus half of BT. This is our equation 2. So one thing I want us to know, all these expressions simply represent OF. It doesn't matter how you move. The whole displacement covered here is the same. So therefore, OF1 is equated to OF2. And Therefore, we are going to equate half of AT plus half of BT from equation 1 or 2 is also equivalent to the other equation A into 1 minus S plus 2 over 5 BS. So whenever we equate two equations which have two different parts, so we are just going to look at the vector. In part 1 of equation 2, we have a vector A. And looking at part 1 again of equation 1, we also have vector A. So I'll equate the two. Therefore, extracting this part should also be equivalent to 1 minus S. Now we can eliminate vector A and we remain with T is equal to 2 into 1 minus S. I've multiplied by 2 both sides so that I can eliminate the half. So T alone is equal to 1 minus 2 into 1 minus S. I can decide to break the bracket between the 2 minus 2S. This is our equation 1. Could leave it here, just break the brackets. Then we have to equate the other part left. So now that I've equated this to this, then this also should be equated. It implies that the other parts are also equal, and therefore half BT should also be equivalent to 2 over 5 BS. 2 over 5 BS. So at this stage, I'm also going to eliminate B, vector B. It is common on both sides, so we cancel. Multiply by 2, multiply by 2. T alone will also be 2 over 5S times 2. So this can be simplified to be 4S over 5. This is another expression of T. So that is our equation 2. So here we have two expressions of T. T from the other two parts of the equation and another T from the other two parts. So T is still T because we are talking about the same T from the same information. So we say T1 should also be equal to T2, and therefore 4S over 5 is equivalent to 2 minus 2S. 2 minus 2S. So by so doing, I shall have eliminated the T's. I'm only left with an equation of S to be able to find the value of S. So multiplying both by 5, both sides by 5, I will be having 4S is equal to 10 minus 10S. Let minus 10S come this side, or I add minus 10S minus 10S. This side will be 14S is equal to 10 over 14 over 14, so that S alone is 5 over 7. Common factor here is 2 goes here 5, 2 goes here 7. So my S, the scalar, is 5 out of 7. So what does it mean? What does it mean? That AF, the whole line AD is 7, the denominator, but F is only taking 5 units of the 7. So therefore the ratio will be 5 to 2, so that when you add them, we shall get the 7. So we can substitute S in one of the expressions of T to be able to get T. So substituting in T is equivalent to, from here, T is equal to 4s, and my s is 5 over 7 all over 5. So this shall be 4 times 5 over 7 over 5. So 5 cancels with 5, as I remain with 4 out of 7. So T is also given by 4 out of 7. So coming to my diagram, we can still indicate something. That one can also really form part of the equation, although it was not asked here. So it means T, which is OF, I said we are going to jump. How many steps? Not the full OE. We are just going to jump now. Total length is 7, but we are taking 4 steps. So here becomes 4, and out of the 7, I remain with 3. So 4 out of 7 of OE. That is where F is. Of OE. That is where F is. So coming back over, we can still find that the two ratios, or the two scalars are already here. That is, S is 5 out of 7 and T is 4 out of 7. So the last part of the question, we were asked to show that E, F, and O are collinear. So collinearity is very simple. I told my students this part is very important, and therefore you never know. Let's pay attention and be able to get the 2 marks. We said section B is 3 marks, and we cannot afford to lose either of the marks. So we are given 3 points. The 3 points are E, F, and O. E, F, and O. We are going to do nothing here. Everything is already done. We are just proving. So do we have, I want you to select at random any 2 points, either EF or OE, whichever, or FO, which one. And remember, please, you don't need to redo this thing. This thing has been done for us. Like I remember very well, we had OE. OE has already been done down here. OE. So OE is given as half of, OE is half of A plus half of B. And also, we also have here OF. OF, expression for OF is here. OF is here. Expression of OF is here. I will decide to take this OF too. They are still all OFs. This is more simpler. OF, which is half AT plus half BT. So OF is already there. Half AT plus half BT. So what do we say under collinearity? I always take an example here, NB, from a more simpler thing that students can be able to understand. For example, let me take ordinary numbers. 5 and 10. We can equate 5 to 10 if we do something to 5. What is it? When we multiply by 2. So pretending this 5 is an x, then this 2 will be the coefficient we are looking at. Or the same thing would have been done on this side of 10. If we didn't touch 5, then there's something we would have done to 10 to make this thing true. That is multiplied by half. So that is what we are going to do here. I'm going to force OE, or confirm whether OE in whichever way can be equated to OF. So it's very simple. I'll take the vectors or the expressions. This is for OE. I'm being told to see whether we can correlate the two with the other one of OF as half AT plus half BT. So at this stage, some good students tend to get lost because they really cannot be able to formulate this. But remember, we have all done the value of t. These things I can see they are just related at. Let me see. Let me substitute the t. T is from our equation. From this side, t is 4 over 7. So 4 out of 7 plus a half of b into the same t. 4 out of 7. So finishing this, we shall be having 2 out of 7 of A plus 2 out of 7 of beta B as OF. So we just now equate the two. 1 over 2A plus half B. So this is where we want to prove now whether this expression is correlated to this. So to do so, I'm just going to pick whichever part. I want to pick this and this because they are all bearing vector A. So half multiplied by something x should be equated to 2 over 7. Because A is common, so I'm not considering A, I'm just looking at the coefficients or the scalars. So what is this x, which we don't know? What is this x like in the case of here? 2x equal to 10, so that x becomes the 5. So we shall multiply this side by 2, this side by 2, so that x alone becomes 4 out of 7. And this was automatically the value of t. So therefore, let's see whether this is also true to the other part. We have only compared this part 1. Let's see whether it is also true with the part 2. So it should therefore imply that half of, let me say k, my own number, should also be equal to 2 over 7 on the other side. What is this k? This k should be like the x we have found here. So at the end of the day, multiply by 2, multiply by 2. So k becomes 4 out of 7. So it is true, therefore, to say that when OE is equated to OF, what we have to do to multiply or with OE is simply 4 out of 7. So we therefore say that 4 out of 7 of OE is equal to OF. Just like what we said here. 2 times 5 is a 10. Or 5 is equal to 10 times a half. And therefore, because this is true, it therefore satisfies the two laws that says 3 points or points are said to be collinear only if, number one is a scalar of the other, is a scalar quantity of the other, as in this case, they can be correlated in form of 4 out of 7 of OE is equal to the other. Or somebody can just say 4 OE is equal to 7 OF. So they are scalars of each other. And also, Roman 2, they have a common point. The common point here is O. You can see they are all sharing OE and OF. So point O. So the 3 points, O, E, and F are therefore collinear because they satisfy the two rules. One must be a scalar of the other, and they must share a common point. Thank you very much, guys. You can follow keenly. It's a long question, but it will earn you all the 10 marks. If you have any query, you can reach me. I'm always ready to assist where there's need. And at New Yankees, our main big deal is to make a difference in the life of our learners. So you can reach me still, like I said, 0720 9685 and 17. We also have projections for 2023 in form of pamphlets, questions well formulated and professionally handled for the learners. Even from 1 and 2, we also have materials for you. Every single subject, well formulated books or pamphlets, answers given and worked out for you. So you can follow keenly even at personal level. You don't need to have a teacher for you to know this thing. Excuse me. Just believe in yourself and move on. Thank you very much, and may you be blessed.